There are more things that we can do with logarithmic and exponential derivatives. So let's look. Determine the minimum point of y equals x squared ln x. So let's remember the minimum point. When you have a graph, the minimum point, the slope of the tangent equals 0. So we'll start with our equation and find the derivative so we can find the slope. This is a product rule, so we'll do derivative of first times second, and first times derivative of second. So derivative of first, 2x, times the second, plus the first, derivative of ln x is 1 over x. Let's clean this up. X squared times 1 over x, that'll just give us x. And minimum point, we said the slope was equal to 0. So we're going to make the slope equal 0 and then solve this equation. We have a common factor of x, so we'll pull that out front. And if two things are multiplied together, either the first one equals 0 or the second one equals 0. So either x is 0 or 2 ln x plus 1 equals 0. Now, x equaling 0. That's actually not possible in this question. And let's look at why. The graph of ln x, a logarithmic graph, looks like this. There's an asymptote at x equals 0. It doesn't actually touch that line. That's an asymptote. So it is not possible for x to equal 0. If you're still uncertain about that, try putting that in your calculator and see what the calculator tells you. It should tell you there's an error. So x equals 0, not possible. Solving this one, we bring the 1 to the other side, divide by 2. So we have minus 1/2 equals ln x. This is in logarithmic form. We'll change that to exponential form. Your base is e, your exponent is negative 1/2, and your answer is x. So e to the negative 1/2 equals x. We now know what x is. Let's go through that again. When you find a minimum is a point where the slope of the tangent equals 0. So we're going to find the derivative because that will give us the slope. This is a product rule, derivative of first times second plus first derivative of second. X squared times 1 over x. We have one more x in the top than the bottom, so that becomes x. We then have a common factor. We'll factor that out. And at a minimum point, the slope equals 0. That's why we have 0 in for y prime. Two things multiply together to give you an answer 0. Either the first one is 0 or the second one is 0. This one is not possible because of the ln x. A logarithmic graph has an asymptote, and the asymptote for this one is at 0. Solving this one, bring the 1 over, divide by 2, and then we change it to exponential form. Your base to exponent equals your answer. The base is e, exponent negative 1/2, answer x. Now how we answer the question? Determine the minimum point. So a point is an xy value. We have an equation for y, and we know what x equals, so we're going to put in e to the negative 1/2 for our x values. Oh, before we do that, we should verify whether this gives us a max or a min. So e to the negative 1/2. If we plug a number into the right, let's say e to the 100. When you take the ln of that, that would be 100. 200 plus 1, so that's going to be positive. Plug a number in here that's very, very small. How about e to the negative 100? When you plug e to the negative 100 in, that becomes negative 100 times 2 plus 1. So this will be a negative. So negative slope, positive slope. We know we have a minimum when e equals negative 1/2. Back to what we were trying to find, we're looking for a point. So we're going to plug this in for our x. So we'll get e to the negative 1/2 squared and the ln of e to the negative 1/2. Squaring e to the negative 1/2. You can multiply those together and get e to the negative 1. And then this one, you can use your law of logs and bring the negative 1/2 down. And you get negative 1/2 times ln e. Ln e, the exponent that goes on e to give you e, is 1. So our final answer, e to the negative 1 times negative 1/2. We'll clean it up a bit, but we'll just verify what happened again. The minimum occurs when x equals e to the negative 1/2. So we plug that in everywhere there was an x up here because we're trying to find y. When you square this, you can multiply those together and get e to the negative 1. This one, we're going to pull the negative 1/2 down front using the law of logs. That would give us negative 1/2 ln e, and ln e is just 1. Clean this up a little bit. E to the negative 1 is 1 over e, and that'll give us negative 1 over 2e. So the minimum point, there's our x value, and there's our y value. Why don't you try this on your own? Determine the minimum point of y equals x e to the 1 over x. Let's do exactly what we did with the last time. Find a minimum, we'll find the slope. The slope is the derivative, and we'll use a product rule. Derivative of first times second plus first. When we take this derivative, you write down what you started with, and you take the derivative of the exponent. This is really x to the negative 1. The derivative of x to the negative 1 is negative 1 x to the negative 2, which is written negative 1 over x squared. Now, minimum is where the slope of the tangent equals 0. So let that equal 0. And let's clean this up. We have an x on the top and 2 x's on the bottom, so that'll leave us 1 on the bottom. And then we have a common factor of e to the 1 over x. E to the 1 over x is multiplied by 1, and e to the 1 over x is multiplied by negative 1 over x. Two things multiplied together to give you an answer of 0. Either the first one is 0 or the second one is 0. Solving this, can you raise something to a power and end up with nothing? No, that one's not possible. This one will bring the 1 over x over. 1 over x equals 1. If we multiply both sides by x, we'll find out that x equals 1. We'll do that again. The minimum point, at a minimum, the slope equals 0. The slope is the derivative. Product rule, derivative of first times second plus first. Derivative of the e rules, you write down exactly what you started with and then take the derivative of the exponent. 1 over x is the same as x to the negative 1. The derivative of x to the negative 1 is negative 1 x to the negative 2, which we write as negative 1 over x squared. We then clean this out, 1x on the top, 2 on the bottom. That will leave us with just 1 on the bottom. So we had 1 on the top, 2 on the bottom. That'll leave us 1x on the bottom. We let the derivative equal 0 because at a minimum, the slope equals 0. And then factor. We have a common factor of e to the 1 over x, multiplied by 1 and multiplied by negative 1 over x. Multiplying two things to give you an answer of 0. Either the first equals 0 or the second equals 0. This one is not possible. You cannot raise a number to an exponent and end up with nothing. On this one, bring the 1 over x over, multiply both sides by x, and you know what x is. Now, is it a minimum? We're going to draw ourselves a number line and put 1 down. A number to the right that would be easy to work with. I'd use infinity. 1 over infinity is nothing, so that's just 1. And e to the 1 over infinity is going to give us 1, so that's positive. Now be careful when you pick a number over here. There's actually an asymptote in this question that would be at 0, so you cannot go beyond 0. So what number could we pick? What about 1 over 100? 1 over 100 is between 0 and 1. 1 over 1 over 100 is 100, which makes that negative. And this is going to be positive. So we'll end up with a negative on this side. Negative slope, positive slope. So we know there's a minimum when x equals 1. We're looking for a minimum point. We have an equation for y, and we know what x is. So let's put 1 in everywhere there's an x, and y will equal 1 with e to the 1 over 1. E to the 1 over 1 is just e. So our minimum point then is going to be 1 for x and e for y. Your job today, on page 3, we have more applications to do, and that's it for this unit. There's more applications after that, and then there's a review exercise. So get those done. There should be an inventory on this, and then you'll be ready for your test. Have fun.